Welcome everyone. The question is the electric potential on the axis of an electric dipole at a distance r from its center is V, it is given. Then the potential at a point at a same distance on its equatorial line will be. Four options are given: 2V, minus V, V by 2 or 0. So if you know the theory, then you know that the at any point on the equatorial line of dipole, just like if I consider this is dipole, this is minus q charge and this is the plus q charge, and the equatorial line on the dipole, at any point on this line of intersecting the dipole, the potential is 0. Okay, so obviously the answer is 0. But if we try to discuss more about it, little more about it, then obviously, it is an electric dipole. What is electric dipole? If the two equal and opposite charges separated by a very small distance, that is a minus q charge and plus q charge, separated by a very small distance, as a 12. 12 is very small. Then the dipole moment is defined as P equal to 2L, that is the separation between them, multiplied by the charge. Obviously, it is a vector quantity and is directed from the minus q charge to the plus q charge, that is directed from the A to B. That is the direction of the dipole moment here. Now, obviously, this O point can be considered as the midpoint of A and B, and the separation between the O and B can be considered as the L, and the separation between A and O can be considered as the L. If I want to find it out, the electric potential at the point P, at this point P, due to this electric dipole, which is at a distance r, just see from O to P, it is already denoted here, the distance is r here, that is, it is on the at any point on the axis of the dipole. Then we can get it, the electric potential at any point at the point P. Obviously, it is due to the two charges. One charge is minus q, which is placed at A. Due to this, we have to find out the electric potential at the point P. So we can say it is the VPA. That is the potential at the point P due to the minus q charge at A, and potential due to B at this point P. So this can be written as potential at the point P due to the point B. So just try to understand that. If I try to write it down, what is the formula of the potential? The formula of the potential, you know it very well, that is Q divided by 4 pi epsilon naught into R, obviously in SI. Okay, so now if I try to write it down, what is the potential at the point P due to the minus q charge at A? That can be written as minus q divided by 4 pi epsilon naught. The separation between the point A and the point P is given here, that is R plus L. So I am just putting down here, that is the R plus L. Okay, plus potential at the point P due to the plus q charge at B. Obviously, it will be plus q divided by 4 pi epsilon 0 multiplied by R minus L. So here q by 4 pi epsilon 0, it can be taken common. So you can say q divided by 4 pi epsilon 0, it is taken common from these two quantities. So obviously it is 1 divided by R minus L minus of R plus L. Simple calculation. Obviously from this R plus L, this quantity, this thing I have taken on the right side because this is subtracted here, and obviously if you just subtract it, then it will be q divided by 4 pi epsilon naught, and here in the denominator obviously R plus L and R minus L, that can be taken as a product. So in the above, it will be R plus L, just a simple calculation, minus of R minus L. So if I just do this calculation, obviously R and R cancels out, but this L will be added up. So obviously I am writing down here the potential at the point P at any point on the axis of the dipole is nothing but it is Q divided by 4 pi epsilon naught, and obviously since this R and R cancels out, so it becomes 12. divided by r squared minus of L square. Here P vector equal to 2L vector Q vector or P equal to 2LQ. If I just write it down, what is the magnitude of this expression, the scalar form of this equation? It is nothing but Q multiplied by 2L. So I am just putting this here. This Q12 becomes P, so it becomes P divided by 4 pi epsilon naught r square minus of L square. So this is the potential at the point P due to this electric dipole AB at any point on the axis. Similarly, if I take at any point on its perpendicular bisector, that is at the point P, how to find it out? So here A and B, at the point A the minus q charge is placed, at the point B the plus q charge is placed, and they are separated by a distance 2L, and O is the midpoint, and obviously on the perpendicular bisector at a distance r from the point O we have to find it out the potential. And so obviously this is r, and since O is the midpoint, so we can say OB is nothing but L and AO is also L. So obviously this POB nothing but it is constitutes a right angle triangle. So and PB is the hypotenuse of it. So the hypotenuse can be written as r square plus of L square. Similarly AP also can be written as r square plus of L square. So the P point is at the same distance from the minus q charge. P point is at the same distance from this plus q charge. So they are both at the same distances. So the potential at the point P now, due to the minus q charge which is placed at the point A, so minus q divided by 4 pi epsilon naught root over of r square plus L square, q divided by 4 pi epsilon naught r, using that formula. Obviously this is the potential at the point P due to the minus q charge at A, and potential at the point P, now I am writing down potential at the point P due to the plus q charge which is placed at the point B, and that is 4 pi epsilon naught root over of r square plus L square. Whatever be the position of the point P on this line, only the value of r will change, the value of r square plus r square L square will change, but both are changing with the same magnitude. Then we can say this potential at the point P due to contribution of the minus q charge and due to contribution of the plus q charge cancels out each other and it is 0. Okay, so potential at the point P at the any point on the perpendicular bisector is 0. So we can say this line OP is nothing but an equatorial line, and at each and every point on this line, this potential, if we calculate even at the down places also, even if we extend this line down here also, at any point on this line the potential is 0 since it is an equatorial line. Okay, equipotential line. So it is a equipotential line. Now try to understand, there are two terminologies they are saying, that is they are saying the equatorial position, equatorial position, and another one is polar position. What does it mean? Okay, among these two positions, what we have discussed in the previous page, that is that this is at potential at any point on the axis of the dipole, and this is the potential at any point on the perpendicular bisector of the dipole. Among them, one is called the equatorial position, another one is called the polar position. How these terminologies come? These terminologies comes from the earth. Let us consider earth is a magnet. Obviously earth is a magnet. Okay, and this is a magnet. Earth can be considered as a magnet. Earth is itself a magnet, and magnet is something like this. This is the north pole of the earth and this is the south pole of the earth. So if I try to find it out the potential at the point P2, this is nothing but at the perpendicular bisector position, and but this P2 point is on the equatorial plane, on the in the equatorial line. So P2 which is actually the perpendicular bisector of this magnetic dipole, we can say this is nothing but gives you the idea of the equatorial position. But P1, which is at any point on the axis of this magnetic dipole, okay, which is the axial position, is nothing but gives you the polar position. So equatorial means the perpendicular bisector position, perpendicular bisector, bisector that is basically obtained here, which is 0 always, and the polar position is nothing but, and this polar position nothing but gives you the axial position what we have obtained in the previous page. So we can say this is nothing but the axial, and this one is axial, and as well as this can be written as also polar. But here the perpendicular bisector can be written as this one can be written as the equatorial. Okay, so now let us return back to the question. The electric potential on the axis of an electric dipole at a distance r from the center V. So we have drawn it. That is a minus q charge and plus q charge constitutes electric dipole, and we have tried to find it the potential at the point P1. At the point P1 at any point on the axis of the electric dipole, and it is calculated, it is V. It is calculated according to question, it is considered, it is V. Okay. Then the potential at any point at the same distance on is equatorial line. Equatorial line means at any point on the perpendicular bisector. We are talking about this one. We are talking about this figure. At any point on the equatorial line. We know that the equatorial line is nothing but the equipotential line, and the value of the potential on this line is 0. So obviously, without knowing too much, since it is an equipotential line at any point on this line, not at distance r, but at all points on the line connecting OP2 on its extension also, the potential is 0. So the answer D is correct here. Thank you all of you.